Okay, guys, now that we understand how to find determinants, we're ready to start solving 2x2 matrices by Crammers rule. This is lesson H.15. Okay, so Cramer, I don't know how much of a history you want on Cramer, but he's the one who is credited with using determinants to solve systems of equations with matrices. If you're interested, there's a Wikipedia page on him. But I've got this example, x minus 3y equals 4 and 5x plus 7y equals 8. And we're going to solve this using Cramer's rule. Well, the first thing I want to do is I want to rewrite this in matrix form. So we've got 1, -3, 5, 7. So there's the coefficient matrix. The variable matrix is x, y. And the solution matrix is 4, 8. All right, so we've got the first step. Now, step A, we're going to break this into steps for you. Step A, find the determinant D of the coefficient matrix. So D equals, and again, it's not the bracket, it's just a straight bar. These are like absolute value bars. We're going to put in that determinant, or sorry, the coefficient matrix. So that's 1, -3, 5, 7. We're going to do the diagonals. So we're going to take 1 and 7, multiply those together, equals 1 times 7 minus, and that's the product of these two. Well, we've got -3 times 5. So this is 7 plus 15 equals 22. Okay, so that's the determinant. Now we're going to find the X determinant. And I've written a description on what you do. And we do that by substituting the solution matrix for the X coefficients in the first column of the coefficient matrix. Here's what that looks like. So we take the X values, this 1 and the 5, and we replace them with the 4 and the 8. 4 and 8, and then the Y coefficients stay right where they were. And then we go 4 times 7 and subtract -3 times 8. So that's 28 plus 24 equals 52. Now we're going to do the same thing with the Y determinant. So step C, find the Y determinant by doing the same thing as above with the Y coefficients. All right, and what we get here is, now we're going to put the X coefficients back, the 1 and the 5. We're going to replace the Y coefficients with the answer matrix, 4 and 8. Do our diagonals. So this is equal to 1 times 8 minus 5 times 4. So this is 8 minus 20. So that equals -12. Okay, so we've got our D sub y, our determinant of y. We've got a determinant of x, and we've got our coefficient determinant, or just what we call the determinant. Now that we have those, we can just go ahead and solve. So x equals d of x, or the determinant of x, divided by the determinant. So that's 52 over the determinant which was 22, which equals, let's just go to standard colors, that's 26 over 11 equals 2 4/11. And then the dy is negative 12, and d is again 22. Reduce that to negative 6 over 11. So we have solved a system of equations using Crammers' rule, which takes advantage of determinants. Pretty simple process. Remember, when you're doing this, you're not going to be writing all the words. So it really comes down to 1, 2, 3, solve. Okay, so let's do this one. Field hockey. Example golf to example field hockey. Do you know what the category for the day is? Can you figure that out? Okay, so what we're going to do is we're going to take this system of equations and we are going to rewrite it as a matrix first, okay? And we've got negative 6, 8, 13, negative 2, x, y equals 17, negative 4. All right, so let's find the determinant. D equals, bring down the coefficient matrix, negative 6, 8, 13, negative 2, which equals, we multiply these two together, negative 6 times negative 2, and we subtract the product of 8 and 13. So that is 12 minus 104, which equals negative 92. Our d of x, determinant of x, is, so we take out these x coefficients and put in the answer matrix. And we keep the 8 and the negative 2 there. So now we've got 17 times negative 2 minus negative 4 times 8. So that gives me negative 34 plus 32. So that gives me negative 2. And d of y, we put the coefficients of x back in, so negative 6 and 13. Replace the y coefficients with the answer matrix. We've got negative 6 times negative 4 minus 13 times 17, which equals 24 minus 221, which equals negative 197. Okay? X equals d of x over d, which is negative 2 over negative 92, which equals 1/46. And y equals d of y over d, which is negative 197 over negative 92, which is 2 and 13/92. So there's your answer. There's your solution. So we did a system of equations using Crammers' rule. You can see it's a pretty efficient way of doing it. You know what? To be honest, it seems a lot easier than doing it with inverses like we did before. You can make that decision. Now, just so that you know, there's an example in the notes online of what happens if there's infinitely many solutions, okay? So I'm going to leave that. You can go online, look at those notes, see how it works out when there's an identity, when the two equations describe the same line. And I'm going to leave it to you to figure out what would it look like if there's no